Hi guys. Today we're going to talk about differential heating and how global wind patterns form across the Earth. So the first thing we need to know about differential heating is the energy is balanced on a large scale on Earth. So the energy coming in at the equator balances out by the energy being released at the poles. On smaller regional scales, though, there's an energy imbalance that exists, and this is due to differential heating. For example, the equator receives more solar radiation, the poles receive least, so there's a difference in latitude on how much heat is distributed at those two places. In addition, it also occurs on an even smaller scale between land and water. So if you've ever been at the beach, you know that land, excuse me, tends to heat up faster than water does. So during the day, the sand will be really hot, but at night, the sand will be really cold, whereas the temperature of the water doesn't tend to fluctuate as much. Okay, so what's the impact of this differential heating? Due to the differences in energy received at different latitudes, temperature and pressure gradients are created. These result in the creation of global and regional pressure systems and wind patterns. So now we're going to look at kind of a model of the Earth over here. Okay, so how do we deal with these global pressure differences? Well, we know that the air is superheated at the equator. So if this air is superheated at the equator, it rises, it becomes warmer, and we know that warm air is less dense, so it creates an area of low pressure, okay, because it's rising, so pressure is the pushing or pushing down on something. So since the air is rising, it's not pushing on our surface. So that's an area of low pressure at the equator. Now at the poles, the air is cold, so it becomes more dense because cold air sinks. Think about being in your basement versus your attic. Cold air sinks, so it creates an area of high pressure. Since it's sinking, it's pushing on Earth's surface, creating a higher area of pressure. So you end up with these two high pressure areas at the poles and one low area of pressure to start with at the equator. Okay, so how do we form wind? Winds are generated due to the mass movement of air caused by differences in pressure. So wind always moves from an area of high pressure to areas of low pressure. Okay, so this is kind of a drawing I made in to diagram what's happening with the highs and lows of pressure. So I just gave you here 1/2 of the Earth, okay? And it's not exactly to scale, but it'll work, okay? So here we have the equator, right here, and here we have the poles. And we know from our slide previous, so this slide here, we know that the equator is an area of low pressure, the poles are an area of high pressure, okay? But it's not quite as simple as that, okay? So at the low equator, that's where the air is really hot, so the air begins to rise up. As it rises up, it hits the upper troposphere and begins to cool. As it cools, it spreads in both directions. So it cools and starts to sink, giving us this region here of high pressure, okay? Because it's pushing down. As it pushes down, it goes in either direction, okay? So it can either go back towards the equator or get kind of pushed up towards the upper latitudes, okay? Now we're going to skip this one for just a moment, okay? We're going to go up here to the pole. We know that the pole is high pressure because it's cold. So that pushes down. As it pushes down, it pushes in both directions. So it pushes here, pushes down towards the lower latitudes. So we notice these two arrows, because these two arrows are converging. They're pushing the colder, denser air. They're pushing air towards each other, pushing that air up. Okay, so here, this is an area of low pressure because this air coming in from either direction is being squeezed up into the upper atmosphere. Okay, so you end up with 4 different areas. You end up with an equatorial low, which is here. This is your equatorial low. And the air rises at the equator, moves poleward, creating an area of low pressure. Check, we got that one. That one's easier to understand. Then you end up with, I'm going to go down to the polar high. The polar high is also easy because the air from the poles sinks, creates an area of high pressure, okay? And then you have these two, the subtropical high and the subtropical low, okay? So the subtropical high is right here. So think like Florida, okay, as a subtropical high, okay? The air rises and moves poleward from the equator. It converges, sinks, and creates an area of high pressure. That's right here. Okay, that's your subtropical high. Okay, so as it's from the low, if it's rising and sinking, that's your subtropical high. Then you end up with your subpolar low. Warm tropical air is forced upward as it meets cold polar air, forming an area of low pressure. So here it's moving, cold air from the poles is coming down, warmer air from the tropics, like Florida, South Carolina, is pushing up. So it's pushing all of that air that's here upward, right? And that's your subpolar low. This is where we live in. We live in a low, like a subtropical or subpolar low, which is what gives us our weather patterns, okay? We will go over this in more detail in class, so if you don't feel super confident with it yet, it's okay, okay? Okay, so now let's look at the Earth as a whole. And this diagram, because it's not made by me in Google Draw, it's a little bit, you can see a little bit of the sinking and rising a little bit better. Okay, so here is your tropical low, right here, right along the equator, okay? And then you end up with the air rising, rises in both directions. As it hits the upper atmosphere, it sinks, coming back down, okay? So it's sinking here. And if it's, as it sinks in both directions. So it sinks this way and it sinks this way. Okay, the polar cell here is sinking. As it sinks, it's pushing this air up here, and this air is going that way. So you end up with these global wind patterns. Okay, so some of them go from left to right, and some of them go from left to right, or from right to left. Okay. And you always just follow the arrow that's at the bottom. So this arrow at the bottom here is going this direction. So the arrows all go this direction. This arrow here is going towards the left. So the arrows here point towards the left. This arrow here is pointing also towards the left. So these arrows here all go towards the left. Okay? You'll notice every arrow that's close to the surface of Earth, because the wind is the air pressure changes across the surface of Earth, goes in the same pattern direction. Right? And these are our global wind patterns. All right, so here are all the global wind patterns throughout the Earth. Okay, so here's the equator, and this is known as the doldrums. The doldrums, you'll notice, if you look at wind, air is just rising there, so there wouldn't be any wind, because wind is a difference between high to low. Air is just rising at the equator, so there's very little wind, and it's known as the doldrums, okay? Then you end up here, because the air rises and then it sinks, so this is known as the trade winds. These are the ones all of the sailors took when they were exploring the New World. They took the trade winds to get to Florida and places in what will be the United States. To get home, they would then use the westerlies, because the westerlies will then take them from the west, and they go east. So it would take them back to Europe. So these ones go from the west, and they're called the westerlies because they originate in the west. Okay, so they go from the west to the east. And then you have the polar easterlies up at the poles, and they go from the east to the west. You always name wind based on where it comes from. Trade winds are a little bit different. They just kind of got that terminology from sailing days. But you always name a wind direction based on where it originates. So these are the global wind patterns. This is one of the probably most challenging PowerPoints you'll have in weather. We will go over it in more detail in class, so make sure you have your questions ready, and I'll see you tomorrow.